All right, welcome to the final video for this installment. Again, we're looking at chapter 2.5 from our textbook. All right, so finally, we're going to do a full proof, no hints, no fill in the blank. We're doing everything from start to finish. All right, so if you look at the diagram and if you look at the given and the proof statements, we can see that this is a statement about segments, okay? So no angles involved. All right, so I see that there is a given statement, which I know is going to go at the top of my proof. So I'm just going to copy that down. Point M is the midpoint of segment RT. And I can go ahead and fill in the reason as well, it's given. I see my destination, right? What I'm trying to prove is that the distance from M to T is equal to the distance from R to S plus the distance from S to M. Okay, so that's going to go at the very bottom. Okay. MT equals RS plus SM. Okay, I can't put a reason here because I don't know how I'm going to get there yet. Okay, I just know that's where I'm trying to go. Right, so let's go back to our first statement. Okay, M is the midpoint of RT. Okay, so point M must be in the exact middle of the segment RT. So if it's in the exact middle, then it's dividing that segment into two equal halves. Okay, so MT is going to be the same length as MR. Okay, so I'll put little red tick marks to just remind myself that those two segments are congruent. Okay. And so let's go ahead and write that. Segment MT is congruent to segment MR. Okay. And so to make that determination, all I did was I based it off the definition of midpoint. Okay, midpoint, point must be in the middle, therefore the left segment and the right segment should be the same length. Okay, so definition of midpoint. All right, so that's my reason. Oh, sorry, I forgot the segment symbol. Okay, well, when segments are congruent to each other, that means that they're the same length. Okay? So I can say the length from M to T, or the distance from M to T, is equal to the distance from M to R. So here I'm just using the definition of the word congruence. Okay. For segments, congruent means equal length. Okay. So what next? Well, I know that, so right now my statement has MT, and I know that the final statement has to have MT, so I'm happy with that. Okay, but somehow I need to change MR and replace it with RS plus SM. So let's focus on the segment MR. Okay. So I'm going to highlight it here in blue. Okay, so there's the segment MR. And oh, look at that. It's made up of two smaller segments. Okay. So RS and SM. Okay, why don't I write that down? Okay. So the distance from M to R, which I highlighted in blue, is equal to the distance between R and S plus the distance between S and M. Okay. Now this seems like common sense or very intuitive to us, but there is a name for this. It's called segment addition postulate. Okay. Two small segments that are adjacent to each other will add up to make a longer segment. Okay, so our reason is going to be the segment addition postulate. Okay. All right, and now we're almost at the finish line. Okay. I have an equation here that says two expressions are equal. Okay, the expression MR is equal to the expression RS plus SM. So that means that I could substitute one expression for another in a different equation. So here, I should number these, by the way. So this is 1, 2, 3, and 4. Okay. So if I take statement 3, which I see has the expression MR, and I already know that MR is equivalent to RS plus SM, I can make a substitution. Right? I can replace MR with RS plus SM, which, oh, would you look at that? That's the last line. Okay. So the way we get to the last line is by substitution. Substitution property, right? I'm substituting this expression on the right for this expression on the left. Okay. All right, so there you have it. That was our first official full proof. I hope that you found these videos helpful. I look forward to seeing you guys in the Zoom meeting and doing some of these proofs together with you in real time.